Okay, our last graph for this series is called a scattergraph, and a scattergraph is used to display pairs of related variables, and this is called bivariate data. Should be an I. And this scattergraph compares science percentage marks with maths percentage marks. So we can see it has a title, it has the maths marks on the vertical axis and the science marks on the horizontal axis. And so we can see that this person here has got maybe 15% for science and 25% for maths. So generally both quite low marks. This person here has got about 82% for science, so did well in science, but only 42% in maths. So good at science, but not quite so good at maths. This person here has got quite a good mark for science, 72%, and also quite a good mark for maths, 72%. And we're reading that going across and that one going down. Okay, so each axis represents a variable and has a scale, and each point on the graph gives two related pieces of information, one for science, one for maths. And there are three types of relationships which can be easily seen in a scattergraph. If it goes up, which this one here does, if I was to put a line of best fit through here, it would definitely be an upwards line. And that means that generally the better you are at science, also the better you are at maths. And this is this positive relationship. A negative relationship would mean that the better you were at science, the worse you were at maths, and that generally wouldn't hold. And if you can't see any relationship, then one doesn't relate it to the other. Okay, so let's try and draw one. So 12 girls were chosen from the class, their height and shoe size was recorded. So here's the data. Now we're not going to be able to fit it all on one page, so I'll have to tell you what the data is. And first of all, we have to work out a scale for each axis. Now it doesn't matter which one you put on which axis, but we'll put height on this axis, and it's going to be in centimetres. And if we go back to the data, our shortest person is 140. Our tallest person is 171, so our scale has to be somewhere between those two, and you usually do a little bit more each side. So if we go, say, from 130 to 175. Now if you don't start at 0, you can put a little scale break there, and we can start at 130, 140, 150, 160, 170, 180. Okay, so we've got our height on the x-axis, and we'll put the shoe size on the vertical axis. So here's shoe size, and so we go back and look at the data. Arrow there, and we see that the smallest shoe is a 7, and the biggest shoe is a 10, and they're half sizes in between. So we'll go back and put that on the vertical axis. So once again we can put a scale break, 7, 8, 9, and we'll see how far up it goes, 10, and of course those are even, and so we can put our halfway ones in, and you would make sure that they are measured evenly, that scale. Okay, so we're now ready. Well, we should give it a title and move it up. I seem to have trouble doing this. And we'll put a title and we'll go height and shoe size. TNHN. And we're ready to plot our points. Move it down. So the first one is 156 and they have a shoe size of 8.5. So 155's there, we'll put our intermediate ones on. So just past that, and 8.5 to here, I put a dot. The next one is 168 and a 9. 168 and up to a 9. You can do it more accurately with your lined paper. 145 has a 7.5. 145 has a 7.5. 170 has a 10. Right up there. 140 has a size 7. 158 has an 8.5. Beside that one. 149 has a 7. 171 has a 9.5. 153 has an 8. 147 has a 7. 7 has a 7. 162 is an 8.5. And 160 has an 8. I'm sorry you couldn't see that from the table, but I got it off that table and I was reading across and plotting each of those data points. Okay, so here we've got our scatter graph, and of course we can see that it is a positive relationship, an increasing trend, which means that in this instant, as your height increases, generally your shoe size increases as well. Okay, so you have a go on page 15. There's one for you to draw in your booklet.